Interrupt handling in real-time operating systems. What are interrupts? Interrupts inform the processor that an external device or a task requires immediate attention of the CPU. Interrupts can be of two types, synchronous and asynchronous. First type, synchronous interrupts. Interrupts which occur in sync with the currently executing task is known as synchronous interrupts. Some examples are divide by zero, memory segmentation error, etc. Usually the software interrupts, they fall under this category. Next one, asynchronous interrupts. These are the interrupts which occur at any point of execution of the task and they may not be in sync with the currently executing task. And these interrupts are generated by external devices connected to the processor, controller, or timer overflow interrupts or transmission interrupts, etc. These are some examples of asynchronous interrupts. How the interrupt handling is done in real-time operating system environment. There are three methods or three interrupt handling routines in real-time operating systems. The first one is direct call to ISR by the interrupting source. Second one is the real-time operating system is first interrupted on an interrupt, then the operating system calls ISR. Third one, RTOS first interrupted on an interrupt, then OS calling a fast ISR, and the fast ISR calls a slow ISR. Now let's see how these three interrupt handling methods are done in real-time operating system environment. Let us discuss the first interrupt routine, direct call to ISR by interrupt source. We know that in the conventional systems, the CPU or the processor calls the corresponding interrupt service routine if an interrupt I happens. But in this method, the interrupting source itself, the hardware source itself calls the interrupt service routine. So here one is marked, this represents the hardware source calling the corresponding interrupt service routine. At that time, CPU may be executing some other process, so that process is to be suspended for some time for the interrupt service routine to be executed. So that is informed through to the operating system. ISR start message is given to the operating system, so that is denoted as 2. Now during the interrupt service routine execution, there may be some event messages that may trigger some other events to be executed. So the IPC messages will be given during the execution of interrupt service routine, and that is represented using 3. Now after the execution of interrupt service routine, the control is passed to the operating system, and that is denoted as 4. So this one is the first interrupt handling routine, direct call to interrupt service routine by the interrupting source. So interrupt source itself calls the corresponding ISR, but in the previous methods that we have discussed for operating system, the CPU calls the ISR. Here the interrupting source directly calls the interrupt service routine. Second method is RTOS first interrupted on an interrupt, then OS calling ISR. In this method, the interrupting source or the hardware which causes the interrupt, it notifies the operating system about the interrupt. That is the first step. So operating system, it will be executing some task. Operating system completes the critical part of that task or complete up to the preemption point of the currently running task, and after that it will save the context K. So that is the second thing done. So after saving the context, CPU, it will call the corresponding interrupt service routine. So that is done in the third step. You can see 3 here. So after saving the context of the currently running task, CPU will call the corresponding interrupt service routine, and the interrupt service routine starts its execution. During the execution, there will be some event messages that should be passed to trigger some other events that is sent through IPC or mailboxes. So event messages generated by the interrupt service routine will be used for initiating other events during the execution of the interrupt service routine. And after the execution of the interrupt service routine, the control goes back to operating system. The suspended process will be again loaded and it resumes its execution. So this is the second interrupt routine, that is, the interrupting source will inform the operating system about the interrupt, and the operating system calls the corresponding interrupt service routine. Now let us discuss an example of this method, that is a mobile device, a touchscreen mobile device. So we all are familiar with the touchscreen phones. So in the mobile phones there will be interrupt service routines corresponding to touchscreen. Whenever a user touches the screen to select an icon or menu, what happens is the currently running task will be suspended for some time, and the operating system runs the interrupt service routine for the touch screen. After executing the interrupt service routine, the OS returns back and it will continue the execution of the suspended process. So this is an example for the second method of handling interrupts. Now let us discuss the third method. Before getting into the third method, we have to understand the two levels of ISRs. So in third method, we have to consider these concepts. An RTOS can provide two levels of interrupt service routines. That is, the first level ISR, which is also called as FLISR or hardware interrupt ISR, and the second level, that is a slow level ISR or software interrupt ISR. In Windows operating system, FLISR is also called as ISR. It is just ISR. And SLISR is called as IST or interrupt service threads. Now what is the difference between ISR and IST? ISR is the highest priority interrupt service routine, while IST is the lower priority interrupt service routine. So whenever an interrupt happens, the operating system calls the interrupt service routine. And what does the interrupt service routine do? It will generate some event messages. We had seen the generation of event messages in the previous method also. So interrupt service routine, it generates some event messages. Those event messages are used for initiating the interrupt service threads. So after getting the event messages from ISR, interrupt service threads will start their execution. So interrupt service routine, this is of very high priority, while interrupt service thread, this is of lower priority. So interrupt service routine, it posts event messages that can initiate the interrupt service threads, and these event messages, they will go to the FIFO queue, and from this FIFO queue each of the event messages taken and the corresponding IST will be executed. Now let us see this third method. So third method is RTOS. It is interrupted on an interrupt. The operating system first calls the fast ISR and the fast ISR calls the slow ISR. So let's see the figure. The first few steps are same as that in the second interrupt routine. So let's see what happens. So the first one, the interrupt source, the hardware interrupt source will cause the interrupt, and the operating system, it will complete the execution of the currently running process up to its preemption point, or the critical part of that particular task will be completed and its context will be saved. So that is the second step. So first step is the hardware source, it interrupts the operating system. The OS, it completes the preemption, completes the critical part of the currently running process and save its context. And third step is it calls the corresponding ISR. The operating system, it calls the corresponding ISR. Now the ISR starts execution. During the execution of the ISR, this is a high priority procedure. During the execution of this ISR, it generates some event messages. These event messages are used for initiating ISTs. So ISTs are the actual procedures, and the ISTs, which are slow ISRs, ISTs are initiated when the event messages are generated by the ISR. So in the fourth step, ISR will generate event messages, and these event messages are stored in a FIFO structure. After the execution of ISR, it will return to the operating system. The control will return to the operating system. Now, what does the operating system do? The operating system, it will check the FIFO queue, and from the FIFO queue, it will take each of the event messages and corresponding ISTs will be executed. So ISTs are same as that of the interrupt service routines, but of lower priority. After the ISRs only the ISTs will execute. So ISR, the duty of ISR is to initiate the procedures, the lower priority procedures used for handling the interrupts. So ISTs will execute. After the execution of interrupt service thread, the control returns to the operating system. Now the operating system will load the interrupted process, it retrieve the context and run the task again. So here in the third method, there are two types or two levels of interrupt service routines. The first one is ISR and second one is IST. So ISR is just a procedure. It is a very high priority procedure which initiates the ISTs. And after the execution of ISR, the control goes to the OS. OS will consider each of the event messages from the FIFO and execute all the ISTs. And after executing all the ISTs only, the interrupted routine, interrupted task will be loaded again and it will be executed further. So these are the three methods of interrupt handling in real-time operating systems.